Captain Eva Cortez, a woman of unmatched courage and brilliance, embarked on a mission to explore the unknown, pushing the boundaries of human exploration. Humanity's thirst for knowledge knew no bounds, and Eva stood at the forefront of this grand endeavor, ready to face the cosmos's greatest mysteries. Her spacecraft, the Phoenix, was a marvel of engineering, equipped with state-of-the-art technology and designed to withstand the harshest conditions the cosmos could throw at it. The destination? Sagittarius A*, a supermassive black hole lurking at the heart of our galaxy, a place where the laws of physics are pushed to their limits. Eva's mission was simple, yet fraught with danger: to get as close as possible to the event horizon, the point of no return, and gather data that could unlock the secrets of these celestial monsters, potentially revolutionizing our understanding of the universe. Little did she know this mission would take her on a journey beyond her wildest imagination, into the very fabric of space-time itself. As the Phoenix approached Sagittarius A*, the crew watched in awe as the fabric of space-time itself seemed to warp and twist around them, a mesmerizing and terrifying sight. Eva, ever the pragmatist, kept her hands steady on the controls, her heart pounding with a mixture of excitement and trepidation, knowing that every moment brought them closer to the unknown. Black holes. Just uttering the name sends shivers down our spines, doesn't it? Regions of space-time where gravity is so strong, so inescapable that nothing, not even light, can escape their clutches. Imagine a giant cosmic vacuum cleaner, sucking up everything in its path. But instead of dirt and dust, black holes feast on stars, gas, and even time itself. How do they form, you ask? Well, picture the most massive stars in the universe, many times heavier than our own sun. When these stellar behemoths run out of fuel, they collapse in on themselves, creating a gravitational singularity, a point of infinite density. And there you have it, a black hole is born. Did you know that time itself slows down near a black hole? This phenomenon is known as time dilation. And if you get too close, you'd experience spaghettification, where the gravitational forces stretch you into a long, thin shape. The boundary around a black hole, called the event horizon, is the point of no return. Once crossed, escape is impossible. Interestingly, black holes aren't entirely black. They emit a faint radiation known as Hawking radiation, slowly losing mass over time. At the heart of most galaxies, including our Milky Way, lies a supermassive black hole, millions to billions of times the mass of our Sun. Suddenly, the unthinkable happened. A rogue gravitational wave, a ripple in the fabric of space-time itself, slammed into the Phoenix, knocking it off course and sending it hurtling towards the black hole's event horizon. Eva fought desperately to regain control, her fingers dancing across the control panel, but it was no use. Alarms blared and sparks flew from the console. The black hole's pull was too strong. As the Phoenix crossed the event horizon, Eva felt a strange sense of calm wash over her. It was a feeling of inevitability, of accepting one's fate. She knew there was no turning back. She was trapped. The once familiar hum of the spacecraft's engines was replaced by an eerie silence, broken only by the hiss of static from the comm system. Eva was alone, cut off from the rest of humanity, her fate hanging precariously in the balance. Gap 3S. But what lies beyond the event horizon? This question has baffled scientists and ignited imaginations for decades. While Eva's journey into the black hole seemed like a one-way trip to oblivion, some theories suggest far more intriguing possibilities. One such theory is the concept of a white hole. A white hole is essentially the opposite of a black hole. While a black hole pulls everything in, a white hole expels matter and energy. Some scientists speculate that black holes and white holes could be connected by a wormhole, a sort of cosmic tunnel through space-time. If Eva passed through this wormhole, she could have emerged in an entirely different part of the universe, or maybe even a different universe altogether. Another fascinating idea is the notion of parallel universes. The multiverse theory posits that our universe is just one of many, each with its own set of physical laws and properties. Eva's fall into the black hole could have transported her to one of these parallel universes, a place where the rules of reality are entirely different from what we know. There's also the possibility of time travel. The extreme gravitational forces near a black hole warp space-time to such an extent that they could create pathways to different points in time. Eva might have found herself not just in a different place but in a different era, either in the distant past or far future. And then there's the singularity itself. the point at the center of a black hole where density becomes infinite and the laws of physics as we know them cease to apply. Some theories suggest that the singularity could be a gateway to higher dimensions, realms beyond our three-dimensional understanding. If Eva reached the singularity, she might have transcended the very fabric of our universe, entering a domain where the possibilities are as limitless as the cosmos itself. These theories remain speculative, but they offer tantalizing glimpses into what might lie beyond the event horizon. Eva's journey may have ended in our universe, but in the grand tapestry of the cosmos, it could have been just the beginning of an even greater adventure. Now here's where things get really interesting. As Eva fell deeper into the black hole, she would have experienced some pretty mind-bending effects. First, there's spaghettification. Imagine being stretched out like a piece of spaghetti. Your body would elongate, with your feet feeling a much stronger gravitational pull than your head. Not a pleasant thought, is it? The intense tidal forces would tear apart every atom in your body. That's what happens when you get too close to a black hole. The gravitational pull is so strong that it stretches your body out into a long, thin strand, a process that continues until you're nothing but a stream of subatomic particles. And then there's time dilation. Time, you see, is not constant, it's relative. Near a black hole, gravity is so strong that it actually slows down time. To Eva, time would seem to pass normally, but to an outside observer she would appear to slow down, eventually freezing in time at the event horizon. This means that while Eva might experience her final moments in what feels like seconds, it could appear as an eternity to someone watching from afar. What happened to Eva in the end? No one knows for sure. The singularity at the center of a black hole is a place where our current understanding of physics breaks down. Perhaps she was crushed into oblivion at the singularity. Or maybe she was transported to another dimension, another universe. Some theories even suggest she could have emerged in a parallel universe, or traveled through a wormhole to a different part of our own universe. The possibilities, like the universe itself, are endless. The mysteries of black holes continue to captivate and challenge our understanding of the cosmos.